Hello everybody and welcome back. So in the final lesson for this week, we're going to be taking a look at render scripts. So whenever we have a ROP, we have a couple of scripts on there that run at different times when we're rendering. And we can run different languages, so we can run HScript expressions or whatever we want, but particularly we're going to look at the Python ones. And I find that for the ROPs in particular, the Python's probably the best to use. I mean, you can do quick little wedging scripts with HScript, and in fact I have covered that in the Vex course. But if you want to do anything much more complicated, Python is really the way to go, and it suits these render scripts really, really well. So at the bottom of a ROP, just a normal ROP geometry output, you'll see there's our list of 5 scripts. Okay. Now I'm going to go through those just now, but I just want to show you my scene so that you can kind of see what we're starting with. So I've done a very, very basic sim just to have something to cache. Okay, I've created a box, rotated it a bit, calculated some velocity, and created a collision object. So just a collision VDB. And then I am also flattening that down a little bit and converting that into a density volume. So also it's a fog, but I'm then renaming it to density. And so that's my source. And inside of the DOP, I just have my normal gas object. I've moved my bounds correctly. I've got a gas dynamic resize, but I've switched max bounds off so that it'll just move with my sim. And I'm sourcing in density. I'm using density as temperature field, so I only need to have the one because in this case it's a really simple sim. And then the only additional thing that I'm doing, I mean actually here I should even switch off combustion. So we've just got a basic smoke sim, but the only extra thing I'm doing here is I've got a volume source for sourcing my collision, right? But I've added a switch. And essentially what I'm wanting to do, and this is an actual example that came up recently that I was working on, is I had a sim, obviously a much more complicated sim, and I wanted to simulate with a collider. But then I realized, okay, but I also need a velocity field from this, but sort of to have the same generic movement as the same field, except that the collider was getting in the way. I was sourcing particles from the top of a character's arm, but there's sort of an upward velocity. And so because there was a collider, the points that are being sourced on the top are not near that velocity field because the velocity field is splitting around the character as a collision object. And so it's not picking up those points off of the top, only ones that are sliding from the bottom upwards. So basically I thought, okay, you know what I want to do? I want the entire sim, and I don't want to go and now have to copy the DOP and run an entirely separate DOP just with my collider switched off. But, especially because what would happen then is maybe at first it's fine, works totally fine, and then I go in later and maybe change a setting here. I change my density or temperature or something. I'll maybe add some turbulence or whatever. And then now I have to remember to do that on 2 different DOPs. And that is just a pain. Okay, it's not a very efficient way of working. So what I do is I go and put in a switch to switch this collision object off. And instead of setting anything in here, I'm going to rely on 2 different DOPs. 2 different ROPs. So when I write out the cache for this for the sim, I'm going to basically have one that caches this whole sim with a collider and another one that caches it without. Okay, and I never have to do anything different. I'm just changing my settings normally, doing everything as I normally would, except that every time I cache, I just grab both ROPs, cache them both, and now I end up with 2 different simulations. One that uses the collider, which is the one that I render, and then the other one which doesn't use the collider, and I use its velocity field to drive my particle simulation on top of that. Okay, so that's sort of a practical example of why we would need to do this. There is also another sort of way. I mean, it's similar, but when you do wedging, right? So in other words, when you want to run the same simulation but multiple times with a different seed, okay, or maybe altering some parameter every time. There is a wedging node, and there's a whole setup for that, but some cases, for example, the render farm where I work, there is no script that correctly picks up the wedge, okay? It's a lot harder to send that to the render farm, and so instead we just use this technique of having multiple multiple ROPs, and we'll have a just pre-render script that goes and changes the seed every time, and that seed is changed to the number on the actual name of the ROP. And so when I duplicate the ROP and create them, then each one is going to trigger a different seed of that same simulation and cache them all out, and then afterwards I read them all in and merge them. And that's a way of sort of keeping your sim light and splitting up across multiple machines to do the same sim and then merge everything in together. And that's obviously only relevant when the whatever you're simulating doesn't interact with one another. For example, pops. If you have pops but not with grains or something where you actually have constraints and some sort of interaction between the particles, when the particles are just free floating and they don't care about each other, then you can actually run multiple sims with different Cs, merge them together, and it'll look like they've all been simmed together. Okay, so that's sort of like an old school wedging technique before the wedge node came along, but sometimes it's still relevant. Like I say, we use this now at work because it's a workaround for not having sort of the ability to send a wedge node to the render farm. But in this case, I'm using it just to sort of have two different alternatives to this same sim. Okay, so that's the context of what we're doing here. And if I click play, you'll see here I have just some smoke being sourced from below, and it collides with my box. Okay, and then same thing, but just switched to 1 here will give me this result with no collisions. Okay, really, really simple. So let's take a look at the ROP. Now, the pre-render scripts, well, the render scripts, right? There are 5 of them, and they trigger at different times. So pre-render script is going to run once only, right before it caches anything. So when I click save to disk or save to disk in background, the first thing it's going to do is run this script, then it will start caching. Okay. And for each one, we can set a language, and we can also switch it on or off if we want to. So you can build a script and then disable it later on if you don't want that. Right? There is a pre-frame script. This will run once per frame before. So it will also run on the first frame. So before the very first frame that it caches, it will run the pre-render script and then the pre-frame script before running any caching. But then on the next frame, it will not do the pre-render script again, but it will do the pre-frame script. Okay, so this is going to run before every single frame. Then there is a post-frame script, so that's exactly the same thing, but just after the frame. So after it caches that frame, it then runs a post-frame script. Now this is after caching the frame to memory, but not writing the actual file to disk. Okay. Then there is a post-write script, which happens after actually writing that file to disk. So it's going to go, you click cache, runs pre-render, then runs pre-frame before frame 1, then caches it, runs post-frame, then writes it to disk, then runs post-write, and then finally, once it's looped through all the frames, doing these 3 in the middle, again and again and again on every frame, then it right at the end once runs the post-render script. Okay, so the beginning and the end one only run once, then these run before frame, and after writing. Cool. So that's what they do, and you'll see that they are just a parameter. string parameter where we can fill in any script, but then there is an actual language to sort of how to interpret that script. So we will obviously set that to Python when we're going to do these. Okay, so let's start and do an actual example to show you sort of how this would work. So I'm going to write a pre-render script. Okay, so before rendering, because this over here, this switch, could you imagine, essentially if I was to do this manually, I would say, okay, I'm going to set my cache over here. Maybe let me just cache 25 frames or something like that. I'm going to set my cache and call this one, so we'll just say with col, so with collider, and then I would maybe have another one without col. And so what I would do is go in, set this to be 0, the switch to be 0, click this, cache. And then after that's done caching, right, before I do this cache, I would go in and set this to 1 and then run this cache. Okay. Obviously, we don't want to do that manually every time, because then that means I have to wait for this one to finish, and then I have to be sitting here and manually doing it. And instead, we can leave Python doing it while we go off and have a cup of tea. So let's do that. So before the render script starts, we just want to set a certain parameter. Well, we know how to set parameters in Python. We've been doing it in our Python shell, Python source editor, right? So we just need to write a line where we just use Python and go and set a parameter. We just set this parameter to be equal to 0 whenever this one triggers. Okay, so let's do exactly that. Now, instead of having to reference the node and then the parm on the node, because I know that I'm just referencing one quick single parameter and doing one thing to it, I'm going to do this line, well, this script in a single line. Okay, so if we're a little bit intimidated by maybe working in these single lines or whatever, sometimes I like to even just use the Python source editor as a way to test the line first before I go and actually apply it. Okay, because it lets us kind of experiment. Also, it's annoying where in order to trigger this and test it, we have to click save to disk and then it has to cache. It's fine in this case because this cache is really light, but much easier to just say, okay, let's test it here. Okay, so all we're going to do is just refer to this parameter on here. Okay, so in fact I could even literally just drag that in. So I'm going to say who.parm, and then it's going to be a path to that node, right, or to that parameter, the input parameter, and I just want to say dot set to 0. Okay, so that is the line that I want, and we can test that works. If I just set that to 1 and I click apply, it changes it to 0. Change it to another number, click apply, changes it to 0. Right, so that works. Now we just want to execute this inside here. So I'm going to put this in here, but I actually just for sort of best practice, instead of giving it a full path, I actually want to just give it a relative path. So we just go // and then .NET1 switch 1 input, just in case I would maybe change the location of this. It's just better because we're in here and we know we just want to go to here. I'm just going to go from this node up to the parent, then into .NET1, and then into switch 1 to its parameter called input. Okay, so that's the only change I'm going to make there. Okay, so, and we obviously can't do that with our Python source editor, because the Python source editor is not a node, so there is no relative path to it, where in this there is. Okay, so once we're ready to test this, I mean, if this was a really heavy sim, what we could actually do is go and set say render current frame or something like that, and just do one single frame as a way to test this. Right, so let me go and do that. I'll double check and go and set this to whatever random number. And then when we click save to disk, okay, it will come in here and we'll see it has set this to 0. Okay, and what it will have done is we'll set that to 0 before actually caching it. All right. So now what we're going to do when we create our other ROP and rename it to without collider, right, is on here we're just going to say set to 1. Okay, so then that, when we cache this one, will set to 1, and when we cache this one, it'll set to 0, and they'll both come out with 2 different results. Okay, so let's actually test this. Okay, so I'm going to set both of them to cache the full range, because then we can actually see that it has worked. And I'll save before I cache, because you always should. And this is on 0, but it doesn't really matter, because both of these are going to change it to whatever we want them to. So when I click save to disk, okay, it takes a few seconds to cache each one. Right, and now when I load a file and just let's copy and paste relative reference, okay, and then we move forward, you see that this one collides correctly. That's great. And then what about this one? So if I copy and then paste relative reference, okay, you see there. So that one has no collider, this one has a collider, but we've been able to do that just with 2 different ROPs. And now we could go in and tweak settings, do whatever, grab these and just cache them. And we end up one with a collider and one without a collider every time. Okay, so that's fantastic. Now there's something else I want to do. You notice that I even mentioned it before it's caching, as I always save, because I mean, obviously when you're caching, it's a very heavy process. Sometimes things could crash, and the last thing you want to do is have prepared everything and then it fails and crashes when you try and cache. So I always save before, but what if you forget that? Okay, like what if you accidentally don't save? So what would really be cool is if the script did it for me. If it said, okay, hang on, you're about to cache, before I go and do anything heavy, let me just go and save your scene for you. Right. Now that's something that we can do with Python. As we spoke about with the who.ui module, you can kind of interact with Houdini. That was interacting with the actual window panes and things. But there is also another module, which we're going to talk about now, that allows us to actually work with our hip file itself. Okay, so saving it or loading it or doing whatever. So let's take a look at this. So it's who.hip file. Okay, and like I said before, if you just go through the who module, like if the global module, you'll find all these sub modules in this list, and you can find really useful ones. Then you go, oh, I can work with my who's.session, or I can change geometry or whatever. So that's how you'll sort of find these things. Now, there are a bunch of things in here. I'm not going to go through all of them, but you can kind of set a different save mode, or you can check whether it's busy shutting down or not. You can merge 2 different files together. But one thing that we're going to do is just save it as a backup. Okay. Alternatively, you could have it save, but that's a little maybe dodgy, because who knows, maybe you want to open up, edit a scene and just sort of test a cache, but you don't want to save yet. Sometimes saving, because it overwrites a file, can be a little bit obtrusive for a for a script to do. You don't really want to interact with things that the user should. If you wanted to do this, you'd have to ask the user, essentially. You'd have to have it pop up with a question saying, do you want me to save your scene for you before you cache? But a safe way to do it is save as a backup, because this just saves a separate hip file and does not overwrite the current file. But then the user can always go, if it does crash, they can go and load that backup, and then they haven't lost any work. So all we would need to do is who.hipfile module and run the save as backup function. Okay, so we can test that out in here. So import who, and we just say who.hipfile.save as backup, and just run that. Okay, and obviously we won't really have seen what that did, but if we just go in here into the backup file, and you'll see there's all sorts of things saved, and you'll see that there's a yeah, I think this is the time over here. So this one, right, has happened right now. Okay, so there's back 26. If I go and run this again, okay, and go file open, there should be back 27. Okay, So you see every time I'm clicking it, it backs up my file, right? So that's exactly what we want to do in here. The problem is we already have a script in here. Now, we haven't spoken yet about how to do multiple lines of code in one line. When we have a parameter, a string parameter, it's one line. Sure, it's easy when we've got a Python source editor to have extra lines because you can actually just type different lines of code, right? But what about when we have a parameter that only has one line, okay, and hitting enter does not give us an extra line? So what we can do is we can use a semicolon to separate lines of code, okay? So if I want to go in here, and obviously the line I want to type is who.hipfile.save as backup, like that. Then if I finish this line with a semicolon and a space like that, what it's going to do is essentially run that line and then run that line separately, okay? Now, I am going to actually be deleting this side, this actual second node, until we're done developing this first one, because then when I copy it, it's got all my scripts in it, and I only have to change one value. Okay, so for now, we're going to stick to just the one. Right? So, on this, it is going to first back up my file, then it's going to cache it, but, well, it's going to set the parameter to 0, and then run the cache. Okay? So that should work perfectly fine. If I do that, it's obviously run the cache correctly. It did set it to 0. And if we go and check the backup files, we'll see that there's a back 29. Okay. All right. So now let's move on to another way of doing multiple lines in parameters. And for this, we're going to actually use a different one of these scripts. We're going to use a post-render script, because there's a few things that I would like to do once this cache has finished running. So one thing I wanted to do is actually create this file sop for me, because after every time, like, well, I mean, not every time. Once there is a file sop, then we don't need a new one. But when you cache, if there isn't a file sop, then, you know, it's annoying. You have to create one, you have to go and link the parameter, you have to click reload, shift your display and render flag to it. It's a lot nicer when you can just click render, and then it would be cool if it created this for us. So I'm going to build a script to kind of do that. All right. So we're going to write this in the post-render script, because it has nothing to do with the frames. It's about when it's completed, when it's done running the entire thing. Then execute this thing and kind of clean up afterwards, or prepare the reader for the same cache. Okay, so we're going to get we'll leave our file here as a reference for now, but we're going to build a script that's going to create this for us. Now, don't forget that we have to set our language to Python. Sometimes it's funny how many times I've forgotten to do this. So you start typing the script, you get it perfect, you've tested it in the Python source editor, you run it, and you're wondering why it's not working at all. And it's because it's trying to interpret it as H script. So just set it to Python. Okay. Now, in here I want to run quite a complex script. Okay, I want to ask the user if they want to create the file sop. So that's one thing we want to do. Then if they choose yes, then I want to create the node, set its position. I want to reference this. So if we go and grab, this parameter and reference it in here, and I want to hit the reload button, and I want to move my display and render flag. Okay, so those are a lot of things that we want to do. Now, having mentioned all of that, if you guys want to go and try and do this yourself, then go and build that script yourself before coming back to the video and seeing that you got it right, because that's a really good way to learn. So what I'm first going to do is build this little script inside of the Python source editor, so we can get our head wrapped around what we're doing. And then we're going to go and back and sort of apply it in here in multiple lines. Okay, so let's import who, and then let's create this. So like I said, the first thing we want to do is actually ask the user if they want a file sop or not. Okay, because it's also a little bit sort of presumptuous of us to go and just create a file swap. Maybe they don't want one. Okay, maybe they just want to write it out and they've got a different scene, a render scene where that's where they've got the file. So we're going to ask them. So we can use our who.ui. Who.ui.display message, right? And we're just going to pop up a message and ask them, hey, would you like a SOP? So we will say render completed. Okay, so we're going to tell them, oh, well, your render is finished. And then on a separate line, so underneath that statement, I want to then ask a question. So I'm going to put /n to give a new line, right? So, and then I'm going to say, would you like to create a file SOP? All right. Now the buttons, we need to give more buttons to this because obviously we're asking them a question. So we need to at least give them the choice of actually answering that question. Okay, so we're going to say the first one, I mean, we could say yes or no, but let's be a little bit more professional and say create file SOP. Because when the button specifies what the action should be, if they haven't read the question properly, at least the button kind of clarifies it. So this is kind of a bit of human psychology when you're building scripts and tools for people, is you need to actually think how they would think. And a lot of the time people ignore messages, they don't read it properly and they just want to click a button. But then the button itself is actually asking them the choice. And then if they're not sure what the choice is, like why is it saying apply, accept, close, well then they'll go back and read properly. Okay. That's just a little hint for you in designing tools, because it's funny when you think that learning the coding is the most difficult thing, but honestly, it's trying to get the users to understand what your code is doing or how to work with it properly that is the most important thing. Right. Sorry, over here I forgot this equals sign. So we're saying buttons equals, and then we're feeding it a tuple to say create file SOP, and then the last option I'm going to have is close. Now I told you last time normally I put a cancel option, but in this case I'm calling it close instead of cancel because really this is post render. They're not able to cancel the whole operation. The operation's already happened. We're just asking them if they want to do something extra. Okay, and so they haven't called this command on purpose. We're just kind of popping up saying, hey, do you want to do this? I can do something extra for you, or no, just close. Okay. So I'm going to ask that question. Okay. So if we click apply, it's going to pop up saying render completed. Would you like to create a file SOP? And I go, no, or yeah, sure, create file SOP. Okay. Now that is just going to return an integer for us. Okay, so we need to actually store that. So I'm just going to call it something like choice. Say, so whatever their choice was gets stored in this variable. And now I'm going to use this. So we can say if choice equals, and remember 0, the first one was the one that we want to execute on. If they just clicked 1, so if choice is 1, then nothing happens. So we just ignore this. So inside this statement here, we want to create a file SOP. We're also going to want to reference things on this render SOP, okay, the ROP. So I want to create a reference to self. So I'm going to say self equals. Now when we're actually working in the render script, we're going to change this because we're running the script on the render, the ROP. We can use who.pwd as a shortcut to say myself, to select myself, okay? So, because that's the print working directory script, which essentially references where the context which you're in. But while we're testing in the Python source editor, we cannot use who.pwd. I'm going to leave it in here as a sort of a reminder for us, but I'm going to comment it out. And I'm going to replace it temporarily with a reference to self equals, and I'm just going to feed it, manually feed it, the ROP. Okay. Now, I want to get the position of this ROP, because obviously when we create this new, we're going to create a file SOP, and we also want to know, we want to set its position. So we're going to do what we did last time, set its position to be equal to this, and then move it down by a unit. Okay. So we'll say self dot position will give us the position of our current node, which we can actually store. So I'm going to say pos equals. And then when we create our node, we're just going to say set position, and then we're going to move it as well. Okay, so let's create the node. Now we want to create the node in here, but because we're not creating an input or output node, there's no way to do it as a direct reference from this node. Okay, so what we need to do is reference its parent first, the geo1, and geo1 will create a new node inside of itself. Okay, and we can do that by going self.parent, because we want to go up one level, and then inside of that create a node, so dot create node. Now if we needed to reference our parent multiple times, I would first actually store this in a variable, self.parent, put that in a variable, and then I'd run parent.create node. But because I know in this case I'm only wanting to reference a parent once, just to create a node inside of it, I can do it in one line. So dot create node, and what am I creating? I'm creating a, if we middle click on here, file. So it's just called file. Right, so we create a file node, but obviously, as always, we create a variable to store that in. Okay, so I'll just call it file. Right, so now we will have created a node, but we want to set its position. So we say file.setPosition. Remember, that's a method of the who.node class. And we're going to set its position to be equal to the position of our ROP. Okay, so we just give it pos. And now we just move it down. As I've said before, you could just alter this vector and actually, like, you know, add some or subtract some from the y or whatever to move it down. But you know, I just find it easier to just say set it to that position and then file.move. It's just visually easier, because now you're saying set it to that, and now I can just choose the offset in very easy and convenient numbers without having to complex sort of add these two vectors together. But you know, adding vectors together isn't hard, but you're not always sure whether pos is it a who.vector type, or is it just an actual tuple that has a length of 2. So it's just easier to do it this way. So x is going to be 0 because we want it to be directly underneath it, but y we're going to be negative because we want to go down in y. So I'm going to just say -1 for now. Or you could set it as low or as high as you'd like. All right, so shall we test this for now? Let's keep our file node over there and sort of move it to the side, but let's actually click apply and see what happens. So first thing it does is it asks us, which is correct. If we click close, nothing happens, which is great. If we click create file sop, you'll see that it creates a file sop right there underneath and works perfectly fine. Okay. But what we obviously want to do now is set this parameter to be equal to a reference to this. Okay, so we would sort of copy and paste relative reference, that kind of thing. And then what else did I do? I clicked reload just to make sure that I've got the latest geometry, and then I moved my display and render flag. So those are still the last few steps we need to do. Okay, so I'm going to delete this one for now. Now, to create the reference, right, I'm going to, on our file, so file dot, I want to set the parameter file, because if we click on here, you'll see that this path, if I hover over, the parameter name is file. Okay, so don't get confused by file, the actual name of the node, and then file, the name of the parameter. And we want to set this parameter to be equal to this parameter. We could do it like this, where it's an actual string. So it's just a string expression. But I prefer to do an actual expression, like a reference, kind of like this, like an actual HScript expression. Or we could do a Python expression. Really, it's up to you guys. But I'll show you a kind of a quick way of doing it. Instead of having to go set expression and then give it an expression language and do a whole thing, there is a cheap way of having one parameter become an actual expression that references another one. And that is to say, we reference our parameter first. The one we're trying to reference is the file parameter on our file node. So we go file.parm, and then we reference the parameter name, which is file. And all we do is we set this to be equal to not a value, but an actual parameter reference. Because when we feed it another parameter, the who module is smart enough to know that, okay, it's given me a parameter. What I'm going to do is create a reference to that parameter and feed it in as an expression in here. Okay, so now what is the one that we want to reference? Well, on our ROP, it's called SOP output. Okay, all one word. Now on here we already have a reference to our ROP, which is self. So we can say self.parm, and then we just call it SOP output. Okay, and then that's all encapsulated in brackets for our set function, right? So let's see if that works. So we click apply, say create a file SOP, and now when I check on here, you'll see that this has created a reference to that parameter. And in fact, it's a relative reference, which is great, which is exactly how it should be, all just by this kind of cheap, quick way of just say setting a parm to be equal to another parm. All right, then the other thing we want to do is click the reload button. Okay, because did you see there it hadn't loaded properly until I hit reload. Okay, so we just on our file node we reference our parameter, which is called let's have a look. Let's hover. It's called reload, and we're just going to say dot press button. Okay, so that we trigger it as though we had the user actually clicked the button, right? And then the last thing we do is we set the display and render flag to it. Now we've done this before, so we won't go into it in great detail. We just say file dot set generic flag, and we go who dot node flag type, right? And the type we're looking for is display, and we set that to be equal to true or 1, whichever one you want. And I'm going to copy this, paste it, and just change the display type instead to render. Okay, so there we are. So now when we click, well, let's delete this one, and now when we click apply, pops up asking us. If we click close, nothing happens, and if we click create file SOP, creates a file SOP here. Do you see it moved my display and render flag already? It reloaded it correctly because we're seeing it, and over here it has an expression that references it. Okay, so that's perfect. So now we want to put all of this into our ROP. So how do we do that? Well, I don't want to go and have to put that in multiple lines here, and every time we put semicolons, and also then you have to tab it in, you then need to put hit spacebar so many times. It's just horrible, right? So instead we're wanting to just reference a multi-parm string. So we can add that as a spare parameter. If we go here and then just add a string right to the bottom, and we'll just call this something. We'll just call it create file. And this will be our create file script. Now, we're creating a string type, which is what we want to do, but you see here multi-line string. This allows us to actually have a string that is multiple lines instead of just one. And we can use this for writing scripts. And you can even see it's designed for that, because as soon as we click this on, there's another option here, which is actually language. So it's asking us, how should we interpret that? Okay. Now, if we say none, it'll just be normal text, but we can choose Python. Now, note that it's this and not here in the callback. Okay. Callback triggers whenever the parameter changes. So if we typed some text and hit enter, it would run this callback script. But that's not when we want to trigger this script. So the callback, we're going to leave empty, and it doesn't matter which one of these it's set to, because we're not using it. What we're using is this multi-line string, and then the language that it interprets it is Python. Okay, so now when we click accept, you'll see it creates an actual script section at the bottom here that we can reference in. Okay, so in here we're going to paste our script. So I'm going to copy this entire thing, including the import who bit, just for safety's sake. Okay, so I've got this entire script in here, and you'll see it even loads and interprets correctly because it's got the different colors. but obviously I'm swapping my myself to just who.pwd, because remember, pwd is going to look at where our current context is, and this parameter that we're in is on this node, the ROP node, so it references itself. Okay, so now this is on here, but we need to execute this script here. Now there is a handy function in Python, so I'm going to actually clear all of this. Okay. Remember, I always told you guys you should clear this, because if you leave stuff in here, every time you open Houdini, it runs the script. Okay, so it's going to run every time as though you clicked apply. So clear that before you close it. Now there's a function called exec, okay, which basically says execute something, execute a script. I'm going to feed you some text, and I want you to interpret it as though it is an actual script and do what it says. Okay. So that's what this execute function does. Now, it's quite a strange one because, well, it's similar to these sort of import and if. You see, with import, we don't do import and then put it in brackets and actually run a function. It's just a sort of a tool of Python, right? So we just say exec space, and then we feed it the string of the script that we want to run. Now, how do we get a string of this? Because if we reference the parameter, a parameter is not a string. Even if it's a string parameter, the parameter itself is just an object. Okay, we need to grab the string from it. So what we need to do is evaluate that parameter. So we're going to reference ourself again, so who.pwd, and then we're going to look at a parm on ourself, and that parm is, we called it create file. And now we just need to take that and evaluate. Because if we evaluate, it returns this as a string. So it's essentially like me, instead of clicking on this actual parameter itself, it's like me grabbing the text from here and copying it and feeding it into this execute function. Okay. So now when this triggers, it's going to say, go to this parameter, evaluate it as a string, feed it into me. I'm going to run that as a script. And then it's going to run all of this and interpret it through Python. Okay, so should we put this into practice and see if we've executed this correctly? So we're going to delete all of our file nodes, and we're also going to be very confident here and actually go and set up our second one. So I'm just copy pasting, calling it without col instead of with col, but then remember we're just going to change our switch value here to 1 instead of 0. Okay. Both of them are interpreting as Python. Yeah, so this should technically work perfectly. Famous last words, but let's see if it has worked. Okay, so we're going to say save to disk. Okay, no errors so far, seems to be running. Cool, it's popped up asking us, so render completed, would you like to create a file sup? Now don't worry about this, this is just here because it's part of the post render script. This pops up when it's caching, but only when it caches over a longer period of time. It takes a little while for this to pop up. So in short caches, you won't see this pop up. But obviously now this has caused it to pause and this is waiting, and so this kind of pops up automatically thinking that it's still busy caching. But it says 25 of 25. So this, don't worry about this. So here we can basically say close so that it will do nothing, or we can say, okay, no, well actually I'd like a file sup. So create a file sup. Okay, and there we go. Oh, and now it's asked us again for the other one. Right. So each one has created its own file sup. Obviously the display and render flag was moved to here and then was moved to here. So that's just sort of a limitation of that. We can't have it on both. Okay. But it's created one under each. And it this one references without col. This one references with col. Okay. It's obviously reloaded it, and yeah, everything seems good. So let's have a look. Yeah, there we go. So if I move this one has cached, and if I click here, this one is cached. Okay. And also obviously the backups I mean, we've been running the script again and again, so there are going to be a lot more backups this time. Okay, so we will have, because we've been testing, every time we've tested, it's created backup files, right? And obviously every time it runs this one, it's going to create a backup, and with this one, it'll create a backup. So that might be a little bit too much, but I don't know. So rather safe than sorry. HIP files don't take up a lot of space unless you actually have things locked inside of them. So yeah, it should be fine. Okay, well that basically wraps it up for post-render script, pre-render script, that type of stuff. Obviously, you also have these pre-frame, post-frame. They work exactly the same. They just run at a different time. I haven't really come across any scenarios where I've ever used a pre-frame script yet, but that does seem very useful because every time before it runs a frame, you can have it do something, which is kind of cool. All right, so I will provide the scene for you in case you want it, but really, I mean, you guys could build any cache. This is not that important or specific, okay? It's more about this. Right, so thank you everyone, and I hope this week was useful for you. And then I look forward to seeing you next week, where we're going to continue learning different contexts of Python and how to apply it, before then finally wrapping up the module and moving on to much more complicated scripts. So we're actually going to build our own pipeline tools. Right, so thank you everyone, and I'll see you next week.